In the previous modules, we have seen collection of statistical data and the process of organizing the data by editing, classification and tabulation. And by tabulation you get different types of tables. And as we know, tables are not very often welcomed by ordinary people who are non-technical. And in other words, you can say that tables are not reader friendly, but tables contain the complete information of your study. And tables are the authentic sources of details. But to make the presentation of your report on your study more attractive, you have to do certain works related to diagrams and graphs, which are developed based on your informations that you have gathered for your study. So, this technique is known as diagrammatic and graphic presentation of data. Presentation of data in the form of diagrams and graphs. And diagrams and graphs are very much attractive when compared to tables. They attract the eyes of the reader. They have got great memorizing effect, and the impression created by diagrams and graphs last for a longer time. And diagrams and graphs make comparison of different groups of data very easy. And of course, there are two types of presentations: diagrammatic presentations and graphic presentations, or diagrams and graphs. And when these two are combined, graphs are more scientific, but diagrams are more attractive. And if you are asked to compare or to comment on the properties of diagrams and graphs, the first response is that diagrams are drawn on plain papers and graphs are drawn on graph papers. But now the things have changed. We are doing everything in computers using certain programs. So, if you are asked to differentiate these two, if you are asked to differentiate diagrams and graphs now, we can say that diagrams are made to make the presentation more attractive, and they are very often not drawn strictly adhering to certain scales, but however there will be certain proportions between the data and the different parameters of the diagrams. But graphs are more technical. Graphs are having well-defined x-axis and y-axis, and the process of making a graph is highly technical. So let us see the diagrams first. There are different types of diagrams. Diagrams in which only one dimension of the diagram is considered. Diagrams in which you are considering the area of the diagram, or diagrams of which you consider the volume, and they are called one-dimensional diagrams, two-dimensional diagrams, and three-dimensional diagrams. One-dimensional diagrams are linear. Two-dimensional diagrams cover a space with length and breadth, or with 2 dimensions, or with area. And three-dimensional diagrams have 3 dimensions, and the volumes of different diagrams are 3-dimensional diagrams are proportionate to the data. So there are 1-dimensional diagrams, 2-dimensional diagrams, and 3-dimensional diagrams. And 1-dimensional diagrams are usually called bar diagrams, because only one dimension of the diagram is usually considered. And among the 1-dimensional diagrams, or the 1-dimensional diagrams are usually called bar diagrams, and there are different types of bar diagrams. There are symbol bar diagrams, subdivided bar diagrams, multiple bar diagrams, percentage bar diagrams, deviation bar diagrams, and broken bar diagrams. In the case of a symbol bar diagram, you are representing the data in the form of vertical figures that are drawn proportionate to the magnitude of the data in each case, and each such structure is known as a bar. So there will be a number of bars depending upon the number of classes, number of frequency classes in the frequency distribution from which you are doing the diagram. And usually, in the case of diagrams also, there will be an x-axis and a y-axis. And data are represented systematically. And you can draw the bars vertically, or even you can draw it horizontally. So whether vertical or horizontal, the bars are drawn based on the magnitude of the data. And only the length of the bar is important. The breadth is not important. You simply see the length of different bars and come to conclusions. A picture of a symbol bar diagram is given here for you to see what will be the general appearance of a simple bar diagram. Perhaps this is the simplest form of representation of data, which is well understood by everybody and which is very convenient to draw. And conventionally, people used to draw such diagrams using scale, pencil, etc. But now, very easily, you can use statistical packages starting from Excel to any sophisticated package you can use to draw a simple bar diagram. And of course, in the case of all other diagrams and graphs also, now options are available in different programs, and for all simple techniques you get options in the case of Excel or other worksheets, and in the case of a little sophisticated diagrams and graphs, you have to use a statistical package of a higher order like SPSS or Statistical. So that's a simple bar diagram. And next comes representation of data in a little more complex forms. And the second type can be called a subdivided bar diagram, where the bars are subdivided into different parts to represent different types of data or different aspects of a particular data. And here an example is given, an example of the number of students in different disciplines in two universities, in University A and University B of a particular state for a particular year. And from the graph, from the diagram, you can see how a single bar can be divided into two or more portions to represent data from different data regarding different aspects. So that is about subdivided bar diagram. And then come multiple bar diagrams. And multiple bar diagrams are bar diagrams in which data from more than one groups are represented simultaneously. An example is the number of students study who study in a university from a particular year to a particular year. And you can make a bar diagram, and diagram is known as a multiple bar diagram, in which each university is represented by a different shade. So for a particular year there will be two bars, one with one shade or color and the other with a different shade or color. And if there are three sets of data, if the data pertain to three universities, there will be three bars like that. So multiple bar diagrams are diagrams in which from a single point you are drawing two or more bars, and the size of the length of the bars the height of the bars may vary depending upon the magnitude of the data. Another type of bar diagram is a percentage bar diagram where the data are getting converted to percentages, and then based upon certain other properties or affinities, it is subdivided into different subgroups. So, in the case of a percentage bar diagram, the interesting thing is that all the bars will be having the same height or same length, and it will be usually getting subdivided into different shades depending upon the classification of the data as per certain properties. You can see a percentage bar diagram attached here, in which the percentage of students in different disciplines in two universities of a particular state in a particular year are represented. The next type of bar diagram is a deviation bar diagram. And deviation bars are projected to both the sides. The axis will be in the center, and above it and below it there will be bars, and positive values are represented above and the negative values below. Profit and loss, export and import, such types of data in which there are values that can be projected in one direction and as well as in the opposite direction are represented by deviation bar diagrams. An example of a deviation bar diagram is also given here, and this deviation bar diagram shows the details of export and import of a particular country for a particular year. Export is given in positive values and import in negative values. And in some cases, if the values that are to be represented in a bar diagram are showing high discrepancies, if some values are very small and the others are very large, it will be difficult to represent this data in a conventional bar diagram. Sometimes, due to the discrepancies in the values, the information could not be included in a single bar diagram, since some values are low and the other values are very high. Under such circumstances, we use a technique known as drawing broken bars. The smaller values are represented in continuous bars, and larger values are represented with a break somewhere on the bar, so that the same diagram can be included in the I mean, the same bar can be, same variable can be included in the same bar diagram. So, when you are including such bars, broken bars, it becomes a broken bar diagram. So, these are the different types of bar diagrams. The simple bar diagram, the multiple bar diagram, the subdivided bar diagram, the bar diagram in which positive and negative values are included, the deviation bar diagram, and the broken bar diagram. So far, we were seeing the different types of one-dimensional diagrams. As mentioned in the beginning, only the length of the bar was important. But when you move to the second type of diagrams, the two-dimensional diagrams, it is the area of the diagram that is important. The length is important, the breadth is also important, or the area is important. And the most widely used two-dimensional bar diagrams are rectangles, squares, and circles. And a diagram in which you are representing rectangles will be very much looking like a bar diagram. But there are certain differences. The major difference is that you are fixing an appropriate width for each bar based on the nature of the data, and you are varying the length of the bar. So the width will be constant and the length will vary. The thing is that the area or the inner area of the rectangle drawn in such a way will be including the data in total. So, a rectangle with a higher area means a larger value, and the rectangle with a smaller area means a smaller data. And as in the case of rectangles, you can represent data in the form of squares also. And as you know, in the case of the square, all the four sides are the same, or the length and breadth are the same. And usually the side of the square is decided based on the square root of the value of the variable, thus making the area of the square proportionate to the magnitude of the variable. So a smaller data will be represented in a smaller square and a larger data in a larger square. And rectangles and squares are popular to some extent only, but the next type of two-dimensional diagrams, which are circles, are more popular in nature. In the case of circle, the square root of the data is taken proportionate to the radius of the line, the radius of the circle. Radius is higher means area is higher and data are large. And smaller data are here also represented in smaller circles and larger data using larger circles. And a particular form of circles is very popular. It's a very popular way of representing things attractively, presenting numerical data attractively, and such diagrams are called pie diagrams. And a pie diagram is a circle which you have divided into a number of parts based on the magnitude of each and every component of or each and every subset of the variable. For example, if you are studying the distribution of students of different disciplines in a university, or for a particular year, for example, you can represent the information in a circle which has been divided into a group of subsets, each portion representing a particular discipline. And for your reference, here is a slide which shows the distribution of students of different disciplines in a particular university in a particular year. You can represent the values themselves also in the pie diagram, and you can give different colors to the different parts of the pie diagram. The data are converted into a scale of 360 units, because the central point of the circle around it has 360 degrees, and it is then subdivided based on the magnitude of each and every aspect or each and every component of the data. So that was about two-dimensional diagrams. The different kinds of two-dimensional diagrams are rectangles, squares, and circles, and of course more uniquely the pie diagrams. And then comes the three-dimensional diagrams. Three-dimensional diagrams are drawn proportionate to the magnitude of the data by finding out the cube root of the data and using it as the side of for example, of a cube, which is a three-dimensional diagram, or the radius of a sphere, which is also a three-dimensional diagram. And the popular types of three-dimensional diagrams are cubes, cylinders, rectangular blocks, spheres, etc. And in case of rectangular blocks, there also you have to fix the length and breadth constant, and you have to vary the height. In the case of cylinders also, in the case of cylinders, you have to make the radius constant and you have to vary the height of the cylinders. In the case of cubes, you are constructing the diagram with the sides of the cubes proportionate to the cube root of the diagram. And you can say that there are, if there is a fourth class of diagrams, besides the one-dimensional, two-dimensional and three-dimensional diagrams, there is a fourth class which can be called pictograms and cartograms. A pictogram is a representation of data in which you are using pictures to show each and every category of that. Usually you might have gone through papers in which males and females are given, the number of males and females are given using two types of pictures. Like that, you can use different types of pictures to represent different aspects, different properties of data, different subsets of the data based on the properties. So they are called pictograms. And the next type is a cartogram. In the case of cartograms, you are using maps of maybe maps of a country, a state or a geographical area to represent certain features of that particular area attractively. Maybe you are representing data of rainfall of different parts of a country, the variation in maximum and minimum temperature in different parts of a country, the contours, differences in contour patterns in different parts of a country, or even the political differences, educational, socio-economic differences, etc. in different parts of the country or different parts of the globe, of the world, can be represented using different colors, different shades, etc. that are made on maps. So they are called cartograms. So that's the fourth class. Pictograms and cartograms form another class of diagrams. So now we know that there are different types of diagrams. The one-dimensional diagrams or bar diagrams, the two-dimensional diagrams in which you consider the area proportionate to the data, the three-dimensional diagrams in which you consider volume of the diagrams proportionate to the data, and the pictograms and cartograms. And as mentioned in the beginning, perhaps more scientific and more technically precise are graphs when they are compared to diagrams. And as you know, graphs are drawn more scientifically depending upon standard scales of measurement and standard units. Usually the diagram will be having, the graph will be having the x-axis and the y-axis, and you know the x-axis and y-axis, and on the x-axis you generally plot one variable, and on the y-axis you plot the other aspect of the variable. So there are different types of graphs. Graphs also can be classified into graphs of time series and graphs of frequency distribution. In the beginning, when we were dealing with tables, we found that there are two types of tables: tables of time series and tables of frequency distribution. And like that, here there are graphs of time series and graphs of frequency distribution. Graphs of time series, as you know, represent data chronologically, and usually on the x-axis we generally take the time, and the value of the variable is usually taken on the y-axis. And graphs of time series graphs of time series are otherwise known as line graphs, and the construction of time series graphs is rather easy, and it requires lesser technical skill. And it can be, such graphs of time series can be constructed on a natural scale or on a ratio scale. I have given an example, a picture of a graph of time series here for your reference. So then comes the next type of graphs, and they are called graphs of frequency distribution. And of course, frequency distribution means a distribution in which you have divided the data into a number of classes, and the frequencies of these classes have been represented. So you will be getting frequency tables in which data are represented based on their frequencies, and from the frequency tables you are constructing graphs of frequency distribution. And there are different types of graphs coming under this heading, and they are histograms, frequency polygons, frequency curves, and ogives. Histograms, frequency polygons, frequency curves, and ogives. A histogram is the simplest among these, which is a set of vertical bars actually, and the areas of the bars are proportionate to the frequency of that particular type of the variable or particular class of the variable represented there. And when taken together, and if you are considering the area of all the bars together, it corresponds to the total magnitude of the sample or population under study. Here you are marking the magnitude of each class or the frequency of each class on a graph paper. Usually the classes, the variable is always taken on the x-axis and the frequencies on the y-axis, and you are marking the frequencies of each and every class, and you are drawing vertical bars corresponding to the values using technical precision and scientific methods, and you are making a histogram. But as you know, now there are computer programs for all these types of jobs, and there also, if you are giving appropriate options, you will be able to construct different types of graphs. So histogram is the first type of a graph of frequency distribution, and then comes the frequency polygon. A frequency polygon is a graph of frequency distribution which is drawn from the frequencies of each and every class of your variable. You are plotting the variables or the variable on the x-axis and the frequencies on the y-axis, and you are marking the frequencies in the body of the graph appropriately, and you are joining them using a drawing scale, and when it is extended to the bottom of the x-axis on both the sides, you get a frequency polygon. And here in the slide here you can see an example for a frequency polygon. And the next type of graph is known as a frequency curve, which is also known as a smooth frequency curve. And the major difference between a frequency polygon and a frequency curve is that here you are not joining the points marked on the body of the graph using a scale, but you are marking them free-handed so that the picture is smooth. And frequency curves are very popularly used graphs, and very often the nature of distribution of populations are studied and interpreted based on the properties of the frequency distribution, like the pickedness of the distribution, the flatness of the distribution, the skewness of the distribution, like that, which we will be coming through later. And finally, there is one more type of graph which is drawn for certain special purposes, and they are called ogives or cumulative frequency curves. And cumulative frequency curves represent the cumulative frequencies of the variable up to each and every class. Up to the first class, up to the second class, up to the third class, up to the fourth class, like that. Or more than above the first class, above the second class, like that. And like that, there are lesser than ogives and greater than ogives. And to draw an ogive, you are adding one more column in the frequency table. As you know, the first column is the column in which the frequency classes are represented. The second column is the class in which the frequencies are represented. Here, we are including a third column in which the cumulative frequencies are represented, and it may be the greater than cumulative frequency or the lesser than cumulative frequency. And using this cumulative frequency, you will be able to draw ogives, the lesser than ogive and greater than ogive. So these are the different types of graphs. The graphs of time series and graphs of frequency distribution. And among the graphs of frequency distribution, the histogram, the frequency polygon, the frequency curve, and the ogives. Thank you.